All right, good evening, everyone. So, as Asir mentioned, we missed the last week's session because of some work. Let's quickly get into the presentation. Okay. Share the screen. So, the screen is visible to you. So, today, what we're going to do is we are going to just have kind of an introduction to the multi-tenant architecture of Oracle database. And this multi-tenant architecture is not new, actually. It had been there since release 12 or the 12C release 1 basically. So since then, it had evolved a lot, and there are a lot to be discussed about this multi-tenant architecture. But then, since this is going to be the introduction for today, we are going to just have some understanding about the whole concept of multi-tenant. And probably with the time to come, of course, we will try to figure out, we'll probably pick a few areas of this beautiful feature, and then we'll try to discuss further in depth about those additional offerings that multi-tenant offers. So let's get started. So it's about the container database. So CDB or container database was, as I said before, introduced in 12C release 1. And it's actually a mechanism of grouping several databases together. Now, we have learned about a few components of the database in our previous sessions. We have learned about an instance. We have learned about the database and what database files that we will come across, and so on, right? So at a very high level, if you take a container database will also have its own instance or the SID, right? So whenever I say SID or instance, you should now recall the components like the SGA, the background processes, and so on, right? So that instance is anyway there for the container database. And this container database will have a common set of read log files, control files, the parameter file if you want, and or maybe the password file as well. So there are a certain set of files that will be common. Now, when I say common, along with that, you will have at least one, or I mean, if you are using it properly, you will be having at least one user database or many databases, right? So in the previous, if you take the non-conventional, or what you call not non-CDB rather. So if you take the non-CDB databases, which we used to have before, if you want to have, or if you want to spin up two databases, there will be two separate instances that will get created. So along with that, the control files, the redo log files, all will be created along with the additional instance, right? So here with the container database, you will have only one database created, and underneath, you will have multiple databases attached. So you are going to share a common instance, a common set of control files, common set of redo log files, and so on. Okay. So the moment you bring your databases together, it becomes a consolidated in a database in one. Okay. So you can combine all these databases and use a single SG or use a single memory structure to cache your data, right? But the thing is that if it is a non-CDB kind of environment, where you'll be having separate instances, which means you will be having separate caches for individual databases. So in the event if a particular database is not really consuming sufficient space from that corresponding instance, it is a waste. But here, since we are bringing many databases together at any given time, you'll be making sure that your instance is, or your instance SGA, for example, is being used effectively. Right? So that is one of the important points that we have to highlight here. So as I was saying here, for user databases, there will be a certain set of attached databases coming by default. But leaving them out, you can you can have an empty container without any user databases attached, but that will not make any sense. But of course, you'll be creating many number of pluggable databases. So thousands of pluggable databases, we call them pluggable databases, can be attached to a single container database. So this feature, this container database concept has become a mandatory component from 21C onwards, which means you will not be able to create a non-CDB database starting from 21C. And now, of course, we are talking about 26 AI. So obviously, you can't create non-CDB databases. So what are the advantages which this container database brings? So it brings us the ability to use our resources efficiently. So as I said before, if you just take the SGA, for example, right now, since we are bringing all the databases together and they will be sharing a common SGA, we will be able to efficiently use our memory structures. And we are not now, for each instance, we need to have a redo, a stream. We will be having our control files, right? We'll be having our, a password file. And of course, from the redos, it might create archive files as well. So that will be there per instance, right? But here, it's not really per instance, we call it a thread. Because instance and thread, they are two different. They are two different actually. But generally, for your instance creation, the first value for your thread would be one. So your undo, your redo, right? They're all attached to a certain thread. So if you are spinning up a non-CDB, then you'll be having at least one thread, and that thread will be having your undo, redo, and of course, for the database, you'll be having your control file as well. Now, each and every time you spin up a non-CDB, your instance has to be created, your control files, your redo log files, and so on. Those have to be created as well. But here, we are sharing those files as well. That way, we are eliminating duplication. Right? And then we also, another important fact is the portability of your pluggable databases. So the databases that we create within our container database, which we call the pluggable databases or PDBs, those can be, transported easily, right? Maybe from one CDB to another. So we will learn a bit more about how these can be achieved in the upcoming slides. Okay, so we'll park it for the moment, but they're transportable. So that means you can easily take from one container database to another container database. Then also it is an very efficient way that it has the capabilities given in order to manage our PDBs. Take a very small example. If you really want, you can take a backup of your PDB. And maybe if there is a failure in one of your data files in the PDB, you can just recover that, letting the other PDBs to work without any interruption. If you want to do performance management, you go to your PDB levels and do your performance management. And also, if there are, let's say if you have 10 pluggable databases attached to your container database, and you need to manage your resources, like, let's say the SGA space allocation, that can also be maintained at a top level, providing certain percentages to your pluggable databases based on the priorities. So you can do many things when you have your pluggable databases attached to your single container database, right? So this whole CDB is what you call the container database, and it becomes multi-tenant the moment you have more than one pluggable databases of your choice, right? So if you are only running a single PDB, right, in your container database, when I say single PDB, I'm not really referring to the default PDBs that comes out of the box. Those are there for certain other activities, but the user-defined PDBs. Let's say you want to run your database, you have your user data, you have your application data, and that can be hosted in a single PDB. Similarly, maybe you have another application running, maybe catering to another organization, and that also can reside in a separate pluggable database, so the data is isolated. So the moment you have more than one user-based pluggable databases, we call it multi-tenant. But if the CDB is only carrying a single user-based pluggable database, we call it single tenant. All right. Okay. So here we are talking about multi-tenant CDBs because we presume that in our environment we are going to run more than one user-based pluggable databases. Okay, so this is the architecture that you find in the in the container database architecture. First, you have the root, right? So root is the top person, whether it is called as a pluggable database, whether it is called the database or the administrative database, right? Whether it is actually called the instance database. So there are different names that interchangeably used by the experts. So it's not very clear whether we could call it the instance database, or whether it is called the administrative or super container, right? Or whether we call it a pluggable database. Because when I say pluggable database, generally the capability is there for portability, right? But generally, I mean, when it comes to root, we may not really, transport the root content itself to a different container database. So still, you have syntaxes in order to take the backup of the root container as a pluggable database as well. So don't worry too much about these definitions, but what we have to understand is root is the central controlling unit, right? So root will be assigned with a container ID 1, right, in your database. And then, so if you are allocating resources, let's say if you are defining your SGA for your entire container database, that top figure or the full figure will be given at the root level. But if you want to give a certain portion of that SGA to one of your pluggable databases, you can define that value in your pluggable database setting, pluggable database value. So as an example, maybe you have given 100 GB for your SGA at root level, but I create another pluggable database called PDB1. So that PDB1 will only be having, let's say, 10 GB. So root has, or the total allocation is 100, but at a PDB level, at that PDB level, we have given only 10 GB. These can be dynamically assigned as well. We will talk about it later. Okay. And then we also have something called as PDB $seed. So this PDB $seed is a template database. It's a pluggable database, but it will be running on a read-only mode. So whenever you initiate a command to create a pluggable database, then this template will be called in order to support your syntax. Then we also have regular. Let me just take the pointer as well, right? So if you take, point option, let's take this here. Okay, so if you take the regular PDBs, see these regular PDBs are the PDBs that I was just talking about. We also have something called as application containers. We'll look into application containers later. But one thing for sure, application containers is a very, I would say, very appealing component that most of the people or most of our DBAs may not know. So I will touch upon application containers. It's a huge topic, extremely huge topic that we can't discuss probably within a day as well. But of course, we will figure out a way how we can discuss about these application containers, because I feel it is going to be extremely important for you as well, because this is not really a very popular topic. Okay, yeah. So then we have the PDBs. PDBs will share the instance, the instance, the SGA that I was talking about, the control file, the redos, and the password file. So they're all shared by a single database. So we have a container database. Underneath, you have your root, which controls the rest of the pluggable databases. And by default, you will get your PDB $seed, which is a template database running on read-only mode. And then you can create your own pluggable databases that will be acting as maybe repositories of for your applications. And then you can run application containers where you'll be running explicit applications with certain version numbers, where you'll be doing sometimes version upgrades, patching, and so on, right? So we'll not go into detail as of now, but let me just give you that idea from a command line perspective as well. So I'll just stop sharing from here, and then I'll take you to my prompt. Just a second. So I hope this is clear. So I'm in a environment where I have uh, installed container database. So we discussed about data dictionary views and dynamic performance views, I think probably in one of the previous class sessions. Let me just do select CDB from $3 database. So you can see here that my database is CDB on. I mean, this is a column that I have retrieved from $3 database dynamic performance view, and it returns me saying it is yes, right? So my database here is a container database. So if you are in a container database, if you put show PDBs, right? Now I'm connected to root. So whenever I exit, let's say if I connect to my instance, right? So here echo $oracle, right? So it's prod 21, that's my instance name. So that is the instance that I've set here. So if I just connect to my database as is DBA, right, and do show con name, it tells me that I'm in the CDB root container, right? So it will have a container ID as well. Show con ID. You can see that the container ID has been allocated as 1. Okay. So if you check your PDBs, the rest of the PDBs, you can see it starts with 2 because root has container ID 1, right? So then the PDB $seed, which is, as I said, running on read-only mode. And so this one is there to support new pluggable database creations. And then you can also see container ID 3, which is a PDB1 currently in mounted mode. The mounted mode means the pluggable databases either can be shut down, I mean, either can be mounted or those could be open. Those are the two status that you will find. So mount means it is not open yet for the users, right? But I can always do alter. So I can give the name here as PDB1, or I can say all open. So these can be separately managed, right? So I can open my PDB1 in read-only mode, right? Or I can open it in a restricted mode so that only a certain set of users can access the database with read-write access and so on. So now, if I say show PDBs, you can see that it has been my pluggable database PDB1 has been started with read-write mode. Okay, so it could be this database that you want to bring up, or it could be another database or another pluggable database. So you can independently manage them. Right? So this is that structure that I was talking about. But when you talk about the my name, container ID from CDB data files. Sorry, let me just do it again. So you can see here, that okay, so container ID 1. So we know what container ID 1 means. So container ID 1 refers to root, right? It is always going to be root. The root's data files are located in this place, right? And then you can see also our ID3, right? So ID3 refers to my pluggable database PDB1. That's my general or regular PDB. And that also has a certain set of data files. But you can see here, it provides us a unique ID. We call it the global ID. for the pluggable database. So that is this. If I had created another pluggable database, it would have assigned another unique or global unique ID, GUID, basically to recognize or isolate the files of that particular pluggable database. Okay, something that you would be able to notice here, I had root. I also had the PDB $seed, right? But any, file reference to PDB $seed is not listed here. So that is how this particular view will return. Okay, so it basically talks about the root and the corresponding pluggable databases or regular pluggable databases data files. But you can also query the dynamic performance view for the data file. So let's accept that as well. Select name on ID to show that we have on ID there. But let's it has on ID as well, but then it will show us the content ID too, which is the PDB $C, which we didn't see when we ran CDB underscore data files, right? So a difference that you can verify or that you can see when you run CDB data files and V $data file. Okay, so V $data file returns the locations and the unique global unique ID or GUID and the path for the files related to PDB $C as well. Okay, right. Okay, so this at a very high level, how the structure would look. So you saw that I managed to bring my pluggable database up. So it could be one pluggable database, or many pluggable database that I can deal with. Okay, right. Let me just stop my screen here again and then switch back to the presentation. Right. So let me get to the presentation here. Okay, so here we were talking about the architecture. Okay, coming back to the application containers. So application containers is a separate concept altogether that lies within a container database. Now the container database comprises of the root itself, right? And then we have the seed for the PDB $C and your regular pluggable databases, right? Now you can see here there's a slight difference, right? When it comes to application containers, where you find your root and one of your pluggable databases becoming an application root. Right? So you can see here in the same root, under root, right? You don't see a root under a root, right? So here, but you have what you call an application root. Maybe you want to deploy an application and you start your application on application root. And then you have your application. Okay, seed is also available just like the PDB $seed. Application seed is there to provide a structural support when you are creating your pluggable databases. Right? When I say structural support, so as an example, just imagine that this particular we can create this separately. Assume that we create this application seed with a particular user created and some data files as well, or maybe table spaces as well. So the moment you create a new database, a new pluggable database underneath this application root, it basically copies all these table spaces, the user that I was talking about, into this new pluggable database. So template is something like that. Okay. So what's the benefit that you find with regards to application containers? So what happens is, as I was saying, so let's say you want to deploy an application. So when you deploy an application, you will have a code, right, for the database. So you can basically say that I have an application and I can give the installation, installation version number and start building my code in my root. And then what happens? You need to end the installation of your application with the end command as well. And after that, you can start synchronizing that to these pluggable databases that you have, right? So when you do a synchronization, whatever you have done here will be propagated to these pluggable databases. Are you going to do the synchronization for both these pluggable databases, or you only want to do it on one? So that is something that you can decide. And there is something called as data linked objects. We have metadata linked objects where maybe application root has some metadata information, or let's say a definition of a table that is exposed to this pluggable database. So as an empty table, or maybe with some data that you have already inserted here at the application root will be visible here. But then for this pluggable database, this table that I was referring to may not allow inserts coming into this table. So it will be more of a reference table that is coming from the application root. But maybe here for this pluggable database, the table that I was referring to, the same table may have data link. It could be defined as a data link object or a data link table or data link common table. Right? So once that comes here, you will be able to see the actual data that you have already inserted at the application root. And maybe for this database also, you can do inserts to that table. So it will have a mix of data coming from the application as well as from the local container as well, or local PDB as well. So these are some of the examples that I just took, right? So the idea here is it's about, like, let me take one scenario as well. Let's say you have a company, or you have a software that needs to run on certain multiple organizations. So one organization would be treated as one database. Treated in the sense your repository will be as one PDB, and for the second organization, I may use this pluggable database. So here I have the software code for the database that can be replicated or synchronized based on the expectations that these databases have. Okay, so I think best thing would be to get to know hands-on how these application containers work. So I will try to come up with a kind of a scenario, and then we might probably take about 2 days in order to do a hands-on activity or a demo there. But anyway, that will give you a better understanding about this whole concept. But since this is just an introduction to our containers, you may do your research to see how well your application containers within our container database concept will help your operations. Okay, right. So let me just move forward with CDB administration. When it comes to container database administration, we can do resource controls. Meaning, I can set a value that will be applicable for all the containers, right? Or it could be applied only at a pluggable database level. Okay, so same parameter, but at certain container levels, container database level, we have when I say containers, right? So container at PDB levels, you can have different values given for those parameters. And then you also have something called as resource manager. So resource manager is again a separate topic, right? And we can define at a very high level what we call shares. So I could say that I have 5 pluggable databases running in my container database. And this is how the resource allocation should take place. As an example, let's say out of, let's say 20 CPUs that I have in my database, 20% of the CPU capacity or CPU allocation, CPU time has to be allocated to PDB1. Just 5% has to be allocated to PDB2. Likewise, you can configure resource manager plans and activate them based on the time that you want, or you can make it a static entry as well, so that dynamically The resources will be allocated based on the priorities that you have across your PDBs. So when I say CPU controlling, that is just one of the things that the resource manager can do. It could be from concurrent sessions. It could be from undo management. And there are various other things that you can really, configure in order to manage your resources or manage your resources, resource distribution across the pluggable databases. Because sometimes what happens is if you don't give a control, if you don't have a control, maybe an unwanted pluggable database might take a lot of space from your SGA because of a bad query executed on that particular PDB. Because it has the right to access the resources from the common instance or common SGA, it might impact the other tenants. It might impact the other pluggable databases. And we call that situation as a noisy neighbor. A neighbor like a PDB is impacting the operations of the other pluggable databases. So these can be easily controlled. Right? So when you are doing your administration at the CDB level, you can have local users defined. Local users are the users that can be defined at your pluggable database level or at a local level. You can also have your common users, which can be defined first at the root level. And the root, whenever you create somebody or when you introduce someone at the root level, that root level user will be replicated or will be synchronized or will be propagated to the rest of the pluggable databases as well. So you will find the same user appearing across all the pluggable databases, right? But then the good thing is that even if you find the same common user appearing across all PDBs, they may have different access rights because you can provide privileges at the root level so that it will be replicated to the PDBs, or you can go to your own pluggable database and assign these privileges separately to these common users as well. Okay, so that way you will have that flexibility of defining rights even to common users at your own local level or at your PDB levels. Just like your users, you will have roles as well. So you can have a local role that will be defined only at the PDB level, which is only applicable for the users who are in that container or in that pluggable database. At the same time, you can have common roles created at the root level, where you can have them have privileges granted to that. And again, indirectly, these roles can be given to common users as well as the local users accordingly. Another important thing about CDB administration is lockdown profiles. So when I say lockdown profiles basically restrict users from doing certain activities, right? It could be a disabling of a particular feature. Example, I don't want the JVM to be used by PDB file. But the rest of the PDBs can make use of JVM, but not PDB file. So I can do a lockdown profile for that. I create one and enable the restrictions and assign it to a particular PDB. Okay. Another example. So if you want to change parameters in your database, you do alter system. Right? So when you do alter system, maybe I don't want this alter system to be used by, let's say, some pluggable databases. So I can disable all the system command. So from there onwards, alter system cannot be used. So you might be a privileged user, but you don't have the right to use. I mean, when you try to use alter system command, that will not work. So at a very nitty-gritty level, at a syntax level also, you can restrict. So this can be applied to a certain set of pluggable databases or individual pluggable databases. So that's up to you. Okay, so that's what you call lockdown profiles. Right? And then we have the backup recovery and performance management. Now this is also, it is easy because now when you have a pluggable database introduced, that pluggable database can have optionally can have an admin user. Optionally in the sense admin user will be there. So you can define an admin user and grant it with the relevant privileges or the roles to that local admin who will be able to manage the users, manage the database within that local unit, within that PDB. Okay. So he can probably do his backup and recovery operations. He can can do his performance management activity. All these things can be done at that container level or at that pluggable database level. All right. So you have that flexibility. So I showed you earlier as well that the PDB was shut down, and then I managed to bring it up. But bringing it up or shutting it down will not impact the rest of the pluggable databases that are running in that container, in that CDB. So that's the thing. So at a root level, you can manage the entire database because root has the visibility to all the PDBs underneath. So if you have access rights to the root and root level, you should be able to manage all the pluggable databases underneath. Another important thing is patching. Now, when it comes to patching, it's now very easy. Why? Earlier days, when you have individual databases running, these individual databases have to be separately upgraded when you do patching, right? But here with the container databases in place, you just upgrade your binary. That has to be done anyways. But with a single command, you would be able to upgrade your catalog or the data dictionary of your pluggable databases underneath just in one command. So all the pluggable databases will be upgraded. So the time of patching, upgrading will always be less. Okay. And then we have this new data dictionary view called CDB underscore. So I think I showed you one example earlier, CDB underscore data files. So when I say CDB underscore data files, it will give you at a container level what are the underneath data files that we have. So I'll take a different example. Let's say CDB tables. So if I want to see all the tables across the pluggable databases, then I will run my CDB underscore tables from root. Right. But if I go to a pluggable database underneath the root, and then I query CDB tables, then that will limit to the tables that I have in that current container, which is that pluggable database. Right. So sometimes you might get confused because the CDB will actually work effectively from the root only. If you go to a pluggable database and run CDB views, then that will be equal to the results returned from DB underscore views. Because your tenant, your pluggable database will not have access to the other pluggable databases in the environment. If you want to do so, have your CDB views access or CDB underscore views access from the root container. Hope that is clear to you, right? Okay, so then we have some more administrative activities which can be done within a container database concept. These are very interesting scenarios or actions that we can take. First one is the duplication of TDB. So you have different commands, right? Including RMAN, in order to simply duplicate your container databases or even a pluggable database, a selected pluggable database from one container to another. Right? In a single command, you should be able to carry out that activity. Because that's the beauty of running databases in a container environment or CDB. Okay. And then we can do PDB unplug and plug. You can take off, you can unplug a pluggable database from a given container. Say you are running one container with 19.23 and you have a new target container database which is running on 19.29. So if you want to take this pluggable database to the latest binary set, simply unplug it, and then you can plug that back to the 19.29 container database, and then just run there is a script that we have to run in order to make sure that the dictionary is updated because you are bringing in an old version PDB. So that's the only time it will take in order to make it proper in that new container database. Right? Apart from that, you can always do cloning, right? So you can do a cloning. Let's say you have container data or CDB1 and CDB2. I want one of the PDBs running on CDB1, which is PDB1, to be copied to the second container with data, or no data, just the tables and the metadata only, right? Or you can have certain maybe table spaces picked. So only a subset of data will be replicated to the other container database. So these are few of the beautiful activities that we can do with cloning. And we also can do relocating. So relocating basically talks about how you can physically migrate from container 1 to container 2. So the difference between cloning and relocating is that the moment you relocate, and from your destination, when you open that database, from the source location, the database will be dropped. So it will be permanently relocated to another container database. We also have something called as refreshable PDBs, where you have a PDB running on, let's say, container 1, container database 1, and you have a copy of that same PDB running on container database 2, and you keep on refreshing that PDB based on a time interval. Every 5 minutes, I need to have changes applied to that copy. So that is called refreshable PDBs. You also have that capability of switching over to the refreshable PDBs if there is a resource constraint on the source container database. And those are all possible with refreshable PDBs. And then we also have the facility to convert any non-CDB database to a PDB. So that facility is also there. Then we also have something called as proxy PDBs. So proxy PDB is basically where, let's say you have one PDB, or maybe several PDBs. Let's say several PDBs scattered around, across multiple container databases. Right now, what you do is from one container database, you create a proxy pluggable database that will have DB links created to the other pluggable databases running on different other container databases. Right? And then what you do is, whenever you want to query data from those additional PDBs, you simply run it by accessing the proxy PDB. So proxy PDB will cater to your requirement by retrieving data from the rest of the sources running on different container databases. So this user will not know whether the data is actually coming from the local database or whether it is coming from remote databases. Okay, so that facility is what we call proxy PDBs. So you can do that as well. Then we also have a new feature. I think this was probably introduced in 23. Right? This is called PDB hybrid read-only mode. So you can have, now when you say pluggable databases, you can open it in read-only mode. So as you can remember, or as you can figure out, when you open your pluggable database in read-only mode, obviously there will be no changes that are permitted. Right? So with the hybrid read-only mode, obviously for general users or generic users, it will reflect as if it's a read-only database. So they will not be able to do changes to the database. Whereas for some users, the database will be opened in read-write mode. Right? So that's kind of an interesting scenario where even though it's a read-only database, a read-only pluggable database, you will still have read-write access to some of the users defined. Okay. Right. So these are some of the additional administrative activities which can be performed using your container database. Okay, so coming on to the last section of the CDB, introduction to CDB. So when you want to do certain administrative activities using the container database, PDB operations, you can actually carry out using several components, several tools. So your creation of container database or doing analysis or exploring. All those things can be done using SQL Pulse itself. But if you want to have your Oracle Universal installer, you can create your pluggable database using OUI as well. And then we also have the database configuration assistant, which we can do create new pluggable databases. Actually, now DBCA supports additional work as well, things like relocating, things like duplicating. All these things can also be done using DBCA. This is not updated properly, I believe, right? In the command line though, but in a silent mode, we should be able to do that. And then an enterprise manager, if you have, that also supports certain activities that you can see here, right? And it will also support the upgrade of 90C database to 23 AI. And then the SQL Developer is another tool that we that you might have come across as well, which will support the creation of new pluggable databases on a already existing container database. Right? And then, of course, to explore the database using certain views, all these things can be done using developer. Right? We also have something called as auto upgrade tool, which will support an easy direct migration from 19C to 23 AI. So these are some of the tools available that you can make use of, but that doesn't mean that you have to explore everything. If you can actually use a single tool, or if you are capable of using a single tool, right, in order to get this work done. Because for me, I minimally use, I don't actually use developer, but I mostly I depend on the DBCA, the silent mode, as well as SQL Plus, right, in order to carry out almost all the work with regards to CDB and PDB management. Okay, so these are some of the tools that are on offer, but you can always explore and figure out what is the most easiest one for you. And the only thing is that if you are talking about team control, you need to have your enterprise manager installed and configured. Then only you'll be able to have these features enabled for you to carry out this administrative work, right? So I think we are more or less getting to the closure of the session today. Probably if you have any questions that you would like to ask, feel free to ask now. Meanwhile, I think there was a question, I think, from Asiri earlier, a request rather, to explain you on certain procedures such as instance recovery. So we'll try to incorporate that as well. Maybe in the next session, we'll try to discuss about that as well. So, and apart from that, I would be very much interested in giving you more details of this pluggable database or the container database management, because that is going to be very important. And these functions that they can do are very impressive as well. Okay, so and I will try to come up with a particular scenario in order to explain in detail about application containers as well, because although it is not really a popular topic, I really see a huge potential in that, and getting to know that is going to be important as well. It's not that easy. It's not straightforward. You need to understand the logics right in order to set up an application container, and then thereafter do the relevant versioning, right, upgrading, so on. But we will be able to discuss it in the class in this session run, and get to know more about application containers. So yeah, so the platform is open for anyone who would be interested in asking questions.
So I have a small question.
Yep. Sir, tell me.
Yes, sir. Go
Sir,
ahead.
I couldn't get the a good idea about the CDB root. Like I got an idea like in the inside the instance we have a CDB root apart, and it contains the pluggable databases, right? So
Right.
inside the root are the detail like inside the root the metadata is stored, right? For the all the other pluggable databases.
Just a second. I'm trying to
Like I
share.
got an idea like in the instance we have a part called CDB root,
Correct.
and it contains the CDB root contains all the pluggable databases, and
Mhm.
the metadata is stored in the CDB root, right? All the like I mean the metadata of the all pluggable databases.
Right. So let me just clarify that. No, when you for your first question, so if I do show PDBs, right? So you can see that container. We start with container ID 2, right?
Yeah.
So your container ID 1 is always going to be the root. All right. So root is something which is part of the container database, but I wouldn't say that the PDBs, the $seed are really coming underneath root.
Okay.
Okay, if you just okay, maybe you can just run through this presentation also. I should be able to share that once again. Okay. 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 So in a way, okay. So in a way, you can. This is actually your application container. Yeah. So here also you can see the PDBs are actually. I mean, it indicates that the PDBs are attached to the root, right? So that's the indication
Yes.
that you have here. Now, okay, so there is a bit of a confusion or concern over how we really define the root. But as you rightly said, the common content, the common metadata will always be stored on root. But if you take this example, the HRPDB, if you take the HRPDB will have its own content. So let's say you have a schema called HR, and that HR will have its own data, right? Tables, and within the tables, the data will be there. So that will not be part of the root anyways,
Ah, okay.
right? But root will have the access to the metadata which the HRPDB has. As an example, in the same thing I told you about the table, right? So let's say we have this table called table one. So if you want, okay, so table one, let's say we have certain number of columns. So that is the metadata that I'm talking about here. But
Okay.
from root also, you will be able to see the table structure of HR PDB's table number one. So when you try to retrieve data, root will go and access that metadata from this pluggable database. That doesn't mean that root will keep metadata of HRPDB inside root.
Okay. Okay.
You get
It
so
connect with the HRDB, right? HR.
that's right. So you can just imagine, it shows as if this is attached to the root, right?
Yeah.
So root is more of, I mean, it's a thing that I was talking about earlier as well. In some content, now if you take RMAN, you can backup your root database as backup pluggable database CDB root or CDB $root. So then we have that impression like it's another PDB, right? But you can even use the syntax sorry, rather than saying pluggable database in RMAN, you can say backup database root. That
Backup.
syntax will also work. So in some definitions, they call root as the instance database or as the instance. But that when you say instance, we have that feeling we are referring to the SID or the SGA, right? So it's not that, but it's called the instance database as well. So there are multiple interpretations given to the root container. But what you can imagine is that it's the central controlling unit. It's a parent. So if I want something to be inherited by the PDBs, that has to be introduced first at the root level. So if I want to give an upper limit to a particular parameter, I can have that upper limit defined at the root level. So the PDBs will also have the same value initially set. But having the root value, whatever you have set as the upper limit, this HR PDB will have a different value also. That can be separately defined. Okay. So if I want, if I want to take a backup of the full database, I need to be in root to take that backup, because root will have the visibility to all the PDBs underneath. But if I'm already inside the HR PDB, then I cannot back up my root. Or if I try to back up another PDB, that will also not work.
So it means so we can back up only the pluggable database, right?
That's possible, yes. You can selectively back up pluggable databases. You can selectively back up certain table spaces of a pluggable database as well.
Oh.
Or a data file, for that matter.
Thank you. Thank you, sir.
Yeah, is it clear now?
So much. Yeah.
All right. Cool. Any other questions?
Do we have a database called PDB0? If it is that true to anything else?
Okay, so as of now, there is no indication of PDB0. So you start with 1, and that 1 will be always for root, 2 for PDB$, and then thereafter the regular PDBs for the application containers. So there's no indication of now if you take okay, it's not shared now. If I take you back to the cookie screen, right? Okay. Showed you earlier as well. For root also, it shows us container ID 1, right? So here root goes as 1, PDB$, 2, and thereafter our user defined or regular pluggable databases. So I was saying that during the container database creation, you will come across, or you will get the $seed. And optionally, you can say if you want additional regular pluggable databases. If not, there will be no PDBs for you initially. But then, of course, you can introduce your pluggable databases. You can also see here, I will just show you quickly. Create pluggable database, PDB2. I can simply create it from I can simply clone my PDB as well. So if I use no data here, then it will be just a structure that I'm getting. It's easy as this. So whenever you want to create a new database, just to create pluggable database. And here I'm not using my PDB$, because I'm just copying the content of PDB1.
Is it copying with the data again? I think it's the data, right?
Yeah. So by default, it is with data. But I would have said here create pluggable database PDB2 from PDB1. If I say no data and then the semicolon.
Yeah, without it. Yeah.
Then, only the structures. That means only if you take the tables, metadata of the table will be there. The structures will be there, but no data. I can also mention exclusions of the table spaces, so that only the selected number of table spaces will be copied. So you can see that in no time the database got created. And if I say show PDB, that will assign the next number. but currently it is mounted because whenever you create a new pluggable database, that will be in a mount state, but it will get initiated the moment you open it. Okay. So here I can say, instead of saying alter pluggable database, PDB2. So if I just say open here, it will be only opening that.
Guys, there is no any restriction for languages, so you can ask questions from Sinhala also. So don't worry about to ask questions.
Yeah. So feel free to ask from any language, any in the sense, single and English only.
Yeah, Sinhala and English.
So
You
now
can ask
see
any other languages, but we can't answer.
You will not understand that. Yes, that's right. So I can see now both my PDBs are up. So I can do alter pluggable databases PDB2, close immediate. So this is how you shut down. Or I can also switch to that PDB like this, alter session set container equals to PDB2. So I can go there. Now the showcon name will tell me that I'm inside PDB2. So if users want to connect to the database, if you want to switch between PD containers, then you need to have the set container privilege. This is a privilege. So this is super admin privilege. You don't grant it to anyone. Unless it is exceptionally required. But they can always connect through a connect string. Now, when you create a PDB2, you will have a connect string available. Service name created, and that will be registered in your listener called PDB2. So if you know a username password using PDB2 service name, can connect to PDB2 pluggable database. So here I can say startup. You can say alter database open read only. So you can see that here, as if I'm working with my local database, but I'm actually local in the sense conventional type of a database. I use the command called read only. Then if I do show PDBs, you have to understand that I will only be seeing my container because I'm inside that, right? And it's opening read only. If I want to switch back, alter session set container equals CDB $root. Now, if you do show PDBs, you can see that it is running on read-only mode. So if you are inside the PDB, you can treat as if you are in your conventional type of a database, and your startup command, shutdown command, all will work as usual. But if you're in root, when you want to modify something on your PDB, you have to say alter pluggable database.
I
So
think
yeah.
you can practice all those things in your test database, because I think it is in it's a container database. I said believe.
Yeah, so there are other things as well when you want to do cloning, things like you need to have your archive mode on, and then local undo has to be enabled. So you can verify that as well. So we didn't have time to go through each and every aspects of it, but there are some conditions to be met. But if you have that, then you can. What I did was a hot cloning, meaning I did not shut down my PDB1 when I cloned it to be clone that PDB1 to be to have a PDB2 copy. So it was done on the fly. So operations on PDB1 was not interrupted, and we didn't want to shut down it. So a consistent copy will be created. It's a point-in-time copy that it will create, but you will not need to shut down your PDB1 in order to take copies. So it's a very interesting topic and very extensive topic, as I said before. So we'll try to find some time in order to go through few important aspects of it in one of the upcoming classes.
Again, the thing we have to give a assignment to them because throughout the courses what we have done yet, can we give them a assignment? Small
You
assignment.
mean, is it something hands-on, Asri, or?
Yeah, no, because they will need to present their what they have identified, what they have learned yet. Because when we are talking about when we are doing that internship in our office, we are giving them to do a presentations kind of a thing. If
Yeah.
I say we will ask them to do a session about the SG, or we have to you have to do some session for about that what you call that container database. So we will give them like that kind of a thing.
Okay, so what we can do is, Asri, we will probably come up with a couple of scenarios. So we'll give them a kind of a scenario type question, and then that will incorporate whatever we have covered. So they can think of the technologies that the scenario is really talking about, and then present it accordingly.
Yeah.
Yeah, so we'll do that.
Again. So, Kavitu, can you stop the recording? So I have to give some announcements.
Yeah, okay.
And thank you, guys.